Okay, beta, look at this paper. This is October, November 2015 and paper 1-2. So the first question is, which list shows increasing length from beginning to the end? So first we have to select the smallest one because increasing. So the smallest one is nano, then micro, then milli, and then centimeter. That's why the answer is C. This is smallest, nano, then micro, then milli, and then centi. So this is the order. So this is the answer in increasing order. Question is, which equation contains only scalar quantities? Only scalar. This acceleration is vector, force is vector, power scalar, work scalar, time scalar, so all three. So this is the answer because all quantities are scalar quantities. B is the answer. Next, question number 3 is the time taken for a satellite to orbit the Earth on a circular path is given by the equation t square is equal to k r cube over m, whereas the radius, m is the mass, and k is the constant. And the question is, what are the SI base unit, mean base units of K? So first we will make this K as a subject of the equation. It is T square M divided by R cube. So first make the unknown or required physical quantities as a subject of the equation. Now T is the time, so second, but square, mass in kilogram, and the radius in meter power 3. So we can write kilogram, second power 2, meter power minus 3. So the answer is C. Look at this. And the next is, which row gives a reasonable estimate of the mass and the speed of an adult running? The mass of the adult is approximately 50 to 70 kg. So 60. There is a 60, this is 60, this is 60. And then the speed, the average speed of the adult, it can be from 4 meter per second to 10 meter per second. So it will be 5. So the answer for the 4 will be B, because this is 5 times 1, 5. So do remember, the mass of the adult is from 60 to 70 average, and the speed of the runner, it can be from 4 to 9, or you can take maximum 4 to 10 meter per second. So this B is the answer. You have to remember the estimations. Next question is question number 5. A student measures the time t for one complete oscillation of the pendulum of the length L. Her results are shown in the table. She uses the formula t is equal to 2 pi L over G under root. To calculate the acceleration of the free fall, what is the best estimate of the percentage uncertainty of the G? So this formula can be written as t square 4 pi square L over G. G percentage required, so make G as a subject of the equation. It is 4 pi square L over T square. Now, the percentage uncertainty of the G is equal to 4 constant by constant. So percentage of L plus due to square 2 times percentage of T. Now calculate the percentage of both. So the length percentage of length is its error 0.001 divided by 0.420 into 100, and percentage of T is 0.1 divided by 1.3 into 100. Now calculate these two and put here. Any answer for the first one? 0.001 multiplied by 100 divided by 0.42, and then 0.1 into 100 divided by 1.3. Use calculator. Okay, after calculation and then putting the value over here, my answer is coming 16. So D is option. Now the next is the diagram shows two complete pulses on the screen of the CRO. A grid of the 1 centimeter square covers the screen. The time-based setting is 1 microsecond. How long does each pulse last? So it starts from this, it ends at this point. So the two boxes are covered for the lasting of this one pulse. So one box is representing 1 microsecond. So 1 and 1, it becomes 2. So the answer is 2 microsecond. This is the last time of each pulse. Number 7. A boy thrown a ball vertically upwards. It rises to the maximum height where it is momentarily at rest and then falls back to his hand. Which row gives the acceleration of the ball at the various stages and its position? Take vertically upward as positive. Mean this upward direction is taken positive. Acceleration has magnitude and direction. So first is rising. When it rises, the magnitude of the velocity decreases, so the negative sign, and is represented by multiply, and the upward direction is given positive. So negative multiplied by positive, answer is minus G. Next. Now at maximum height, okay, leave it for the moment, falling, it's coming down. So look, for the falling, the magnitude of the velocity increases, the positive sign, multiply by the direction. Now the direction upward is given positive, so the downward will be the negative. So positive multiply by negative, again minus G. So upward minus G, downward minus C, so definitely at the top minus C, so the answer is B. So do remember, if we use G in equations, then for the upward motion, it's minus G. For the downward motion, it is positive G. But in all other situations, for the graph, for the statement, if upward G is negative, then downward is also negative. If downward is positive, then upward is also positive. So this is a situation.
So while it's downward
we
negative,
have to consider both the magnitude and the direction. That's why upward is negative, downward is also negative. So at the maximum height, the G is same 9.81, so it's also negative. Question number 8. The curve line PQR is a velocity time graph for a car starting from the rest. What is the average acceleration of the car over the first 5 seconds? Look, this is velocity time graph. Definitely the gradient. So the gradient of the line PQ, this line, will give you the acceleration, the average acceleration. And number 9, the ball released from the rest above the horizontal surface. It strikes the surface and bounces several times. The velocity time graph for the first 2 bounces is shown. What is the maximum height of the ball after the first bounce? What is the maximum height of the ball after the first bounce? So look, initially it is dropped from rest. So this is downward motion. It is represented by this. It strikes the surface, it bounces up. And this line is representing the upward journey after the first bounce. So we have to calculate the area of this. This area, 1 by 2 base 0.3 to 0.5, it is 0.2, multiplied by its height is 2. So the answer, 2 ones are 0.2. Look, the answer is it. So this is fall, and this is rise first time. Then this is the fall next time, and here will be the rise next time. So you have to actually calculate the area under this portion of the graph for the first bounce. Question number 10 is, a bus takes a time of 25 seconds to reach the constant velocity while traveling in a straight line. The graph of the speed v against t is given. So this is v and t graph. Look here, the gradient is constant, and the gradient is acceleration, and acceleration directly proportional to force. So for this portion, the gradient constant mean acceleration constant, so force constant. So initially the force is constant only A. This is wrong, this is wrong, this is wrong, A is option. Because acceleration constant, because the gradient constant, acceleration constant, then the force constant. So A is option. Next, question number 11. A single horizontal force F is applied to a block X which is in contact with a separate block Y as shown. The block remains in contact as they accelerate along the horizontal frictionless surface. Air resistance is negligible. X has a greater mass than Y. Which statement is correct? The acceleration of the X is equal to the force divided by the mass of X. No. Because force divided by total mass is the acceleration, not the mass of X alone. The force that X exert on Y is equal to F. No, because the force depends on the mass, and the mass of Y and X not equal. So wrong. The force that X exert on Y is less than F. The force that X exert on Y is less than F. So look at this. Force that X exert on Y is less than F. So definitely the mass of the M is small. So the force exerted at the Y is smaller than the F. So C is the answer. Because F is equal to MA, and the mass is taken of the object at which the force is exerted. So the force exerted at Y. So we will take the mass of this Y. The mass of the Y is smaller. The force is smaller than the total force exerted. Next.
Sir, can you explain this again?
Number 12. A mass of the 0.25 kilogram is suspended from the lower end of the light spring. A second mass of the 0.1 kilogram is suspended from the first mass by the thread. The arrangement is allowed to come into static equilibrium, and then thread is burned through. At this instant, what is the upward acceleration of the 0.2 kilogram mass, assuming G is 10, not 9.81? So the question is, what is the upward acceleration? A is equal to F divided by M. So read it again. A second mass, 0.1, is suspended from the first mass by the thread. The arrangement is allowed to come into the static equilibrium at the instant when the upward force of this 0.2 kg. What is the upward acceleration of this? Okay. So when it is burned away, the total force exerted downward, total force before the burning of the thread is 0.30 kg mean 3 Newton downward total force. But when this mass is removed, upward force due to the stretchiness of the spring is 3, and the downward force this mass is 2. It means the resultant force is 1 Newton. So acceleration A is equal to F divided by M, resultant force 1, and the mass which is moving is 0.2. So 1 divided by 0.2. Answer is 5. I repeat this. So initially, what is the load? The total load in the hanging situation is 0.3 kilogram multiplied by 10, 3 Newton. So the spring can exert force upward 3 Newton initially, but when the thread is no more there, only weight acting downward is 2 Newton. So what is the resultant force? 3 spring upward force, 2 Newton downward. The resultant is 1 and the mass is 0.2. A is equal to F by M. Answer is 5 meter per second square. Next, an object of mass M traveling with the speed V has head-on collision with another object of mass M traveling with the speed V in the opposite direction. Two objects stick together after the collision. What is the total loss of the kinetic energy in the collision? An object of mass M traveling with speed V, so its kinetic energy is half mv squared. Collides with another object of the mass M traveling with this, so 1 by 2 mv square. So the total kinetic energy becomes mv square half mv square, it becomes mv square before collision. The two objects stick after the collision. What is the total loss? So look, formula is m1u1 plus m2u2 is equal to m1v1 plus m2v2. So initially this is mv, and the other object is moving the opposite direction, so minus mv. It means the initial momentum becomes 0, so the final momentum is also 0. It means that finally when both stick together, they are not moving, one object going in this direction, other in this direction, they become stationary. So it means whole of the mv becomes 0, mean whole of the potential kinetic energy is lost. So answer is C. I repeat, both objects are moving in the opposite direction. One has momentum positive mv, other minus mv. Initial total momentum 0, final total momentum is also 0. Both stick together, mean both are at rest after collision. So when both are at rest after collision, so whole of the kinetic initial is lost. So initial kinetic energy mv square, so mv square is lost. Next, number 14. Two identical spheres x and y approach each other with the speed shown undergoes a head-on elastic collision. What are the velocities of the sphere after the collision? Two identical, they have same mass. If the collision is perfectly elastic, if the mass is same, collision is perfectly elastic, definitely they will exchange the velocity. So this is moving in this direction with 4, this will be moving with this direction with 2. So the answer is C. So do remember, when the objects are identical and the collision is perfectly elastic, they will exchange their velocities. So this is moving with 4, this 4 becomes its velocity, this is moving with 2, this becomes its velocity. So answer is C. And it can be proved by relative velocity of separation is equal to minus relative velocity of approach. Next, very simple. Which pair of the forces act on the couple of the circular object? This is not couple because this is F, this is 2F, 2F, F. and both are not parallel to each other, so definitely is the answer. And the next. A car of the mass 500 kilogram is at rest at the point X on the slope. The car brakes are released and the car rolls down the slope with the engine switched off. At a point Y, the car has moved through a vertical height of 30 meters and a speed of 11. What is the energy dissipated by the friction forces when the car moves from X to Y? So you have to calculate mgh here. You have to calculate half mv square. The difference of two energy is the loss of energy as heat. So mgh minus half mv square. M is 500, G value is 9.81, and the vertical height is 30, 1 by 2, the mass is 500, and the speed is 11 square. So after calculation, it is coming 1.2 into 10 power 5. This is the loss of the energy. This is the energy dissipated as heat, because some of the energy is lost and remaining become the kinetic energy, the difference of these two. Next, 17. In which situation is no work is done? Air in the bicycle tire is released because of the puncture, work is done. The ball is dropped, work is done. A box moves at a constant speed across the smooth horizontal surface. A crane lifts a steel girder at the constant speed. So a box moves at constant speed across the smooth horizontal surface. Look at this. In which situation is no work done? Work is done here. Work is done here. The box moves a constant speed across the smooth horizontal surface. Crane lifts a steel girder at a constant speed. So work is done. So answer is C. Next, number 18. An electric railway locomotive has a maximum mechanical output power 4 megawatt. The electric power is delivered, mean input voltage. The overall efficiency of the locomotives converting the electric power to the mechanical power is 80%. What is the current from the overhead wires? Look, power input is equal to IV, and 80% of input power IV is 4 megawatt. And 4 mega mean 4 into 10 power 6. So we will write 0.80, multiply by current required, multiply by voltage 25,000 is equal to 4 times 10 power 6. So the current is equal to 4 times 10 power 6 divided by 25,000 divided by 0.8, and after calculation, the answer is coming C. Because input power is IV and 80% of the input power is equal to output. So 80% of the input power is this, you can calculate, and power is IV. So number 19 is the table, summarizes some description of the evaporation. Which row of the table is correct? Is similar to O-level syllabus. Involves a change in the state from liquid to vapor. Yes, where liquid is converting to steam and causes at the fixed temperature. No, it occurs at the all temperature. Involves a reduction in the average kinetic energy of the remaining. Yes, true. Remaining liquid becomes at low temperature. It remains. So B is the answer. So temperature drops. Next, number 20 is diagram shows a cross section of an Olympic-sized swimming pool filled with water. It is not drawn to a scale. The density of the water is 1,000 kilogram per meter cube. what is the difference in pressure between X and Y? So the pressure depends on the depth. So this is the depth and this is the depth. So pressure difference is equal to rho G delta H. The rho is given. It is 1000. G value is 9.81. And what is the depth difference? 2.35 minus this 2, because this is 2, this is 2.35. So 2.35, so minus 2 is 0.35. So this is the pressure difference. And it is approximately coming 3400. So these answers.